This is video 265 and I'll be talking about the reflection of light. Reflection of light is one way that our light rays can interact with matter. Reflection is when the light ray hits a boundary and then is reflected back into the same medium. So if this is medium number 1 here, let's say air, and then the reflective surface here is medium number 2, then the light ray is coming from medium number 1 and then reflected back into that same medium. What is really cool about reflection is that we know exactly how that light is going to reflect. Reflection of light follows the law of reflection, which says that the angle of incidence is equal to the angle of reflection. The angle of incidence is right here, theta I. The angle of reflection is right here, theta R. So when light is incident, hence angle of incidence, it's incident from this medium, it's hitting the surface, then this angle at which it was incident is equal to that reflected one. A thing that is very important to note when using this law of reflection is that the angle is measured with respect to the normal to the surface. Definitely want to underline this 5 times, right? So the normal to the surface is a line that is perpendicular to the surface, a 90-degree angle. So the ray is incident from this direction, but notice that we didn't define this angle over here. We looked at the angle here that was touching this normal line, this line that is perpendicular to the surface. So even though it's true that this angle would equal this one, if these two are equal, then those two have to equal as well. We're always going to be talking about the angle that touches the normal. That's a way for us to be consistent. Otherwise, if one person talks about this angle and one person talks about this one, then we never know what anybody is talking about. So always use this convention of looking at the angle that touches that normal line. Let's do an example here. A light ray is incident on a horizontal surface right here. So this is the incident ray right here. Incident. And then it's going to reflect, and then it's going to hit this vertical surface, and then it's going to reflect here. So there are actually 2 reflections occurring here. There's a reflection here, and then there's another reflection here because there are 2 surfaces. And I ask, what's the angle of reflection from the vertical surface, from this surface? So let's use the law of reflection that says that the angle of incidence equals the angle of reflection. Whenever we use this law, we always draw a normal to the surface. There we go. Perpendicular to this horizontal surface. And this is theta I right here. So that means that this theta I is going to be equal to 90 minus 35 because the right angle is 90 degrees. So 90 minus 35, which is going to be 55 degrees. So that's our angle of incidence, which means that it's also our angle of reflection. So the angle of reflection is also 55 degrees. So now let's look at what happens over here. We've got 55 degrees right here, but we need to know, well, what is the angle of incidence on this vertical surface? So what you should be able to see if you play with your geometry and your angles, that is something that we have to know a lot about is geometry. Our angles add up to 90. In a triangle, angles add up to 180. So if this is 55 here, then we know that this is 35 over here. And then we have a triangle here. This is 90 here, because these are 2 perpendicular surfaces. Then we know that this angle over here is also 55. It's the 90 minus 35. So now what we're interested in is the angle of incidence on this surface. So if I draw the surface over again, if we have an ray of light going this way, if this is 55 here, and we draw a normal to the surface, I always like to use a dashed line, a straight dashed line for that normal here, then we know that this angle here is 35 degrees. That's the angle of incidence for the second surface. So if the angle of incidence is 35 degrees, then that means that the angle of reflection here off of this vertical surface is also going to be 35 degrees. So our final answer is actually 35 degrees is going to be our angle of reflection of the vertical surface. Vertical surface. Let's look at one more thing in this video here, and that is the two different types of reflection that can occur. There is specular reflection, which is reflection from a smooth surface, and diffuse reflection, which is reflection from a rough surface. In case you can't see it here, there is an object right here, which I have a black line here, but the light here is reflecting off of a horizontal surface. So when the surface is very, very smooth, then if you have a bunch of incoming rays that are parallel to each other, then they're all going to reflect also parallel to each other. The angle of incidence here will be equal to the angle of reflection. Now when you have a rough surface, and we don't mean a very rough surface, anything that is rough, even a piece of paper, right? Anything that is rough compared to the wavelength of the light here. So when the surface is rough, the rays still follow the law of reflection, but what happens is that it's reflecting off the different bumps here that make the reflected rays go off in all directions simply because of the bumps. But it's still following the law of reflection. If you draw a line perpendicular to each surface here, the two angles are always the same. So the diffuse reflection is more realistic because surfaces tend to be rough. Specular reflection occurs for surfaces such as mirrors, but we're going to pretend for the rest of the notes here that our surfaces are smooth, just so that we know exactly the way that the rays are going to reflect. So I have one question related to this. This is an interesting application here. So pardon the wording here. I couldn't word it exactly like I wanted to, but while driving at night, it is easier to see a dry road than a wet one. So I'm talking about you're driving at night, you're on the highway, you got the beams on, it's very dark out. So you rely on seeing things with your headlights. So this is your car over here, and you're driving this way, and you've got your headlights that are shining on the road. And so the question is, why is it easy to see a dry road? So is that an example of specular reflection or diffuse reflection, or is that just an example of light not being reflected from the road? So light is always going to be reflected off any surface, so it's definitely not C. But what allows us to see a dry road at night is diffuse reflection. So diffuse reflection means that the surface is rough and the light will reflect in all directions. So yes, there is some light that is going to reflect back this way, but because of the rough surface, there's also some light that is going to reflect into our eyes, and we learned in a previous video that's how we see things when light reflects into our eyes. So diffuse reflection that reflects this light in all directions is what allows us to see the road in front of us. Now that being said, when you have specular reflection, such as when you're driving and the road is very wet, so that makes the surface of the road very, very smooth, and that's why it can be specular reflection. Think about what happens when you have a car that is coming towards you and it shines its headlights, and let's say this is a wet road, this was a dry road here. That wet road, you're going to have specular reflection. All of the rays are going to reflect in that same path here. So if you're over here, you can kind of get blinded by this incoming car because you do see a lot of light coming from it. But the car itself has a harder time seeing because none of the light from its headlights are going back into its eyes. So it works both ways, that diffuse reflection makes it easy for you to see, and specular reflection makes it harder for you to see, but it also can inconvenience another car and make it harder for them to see as well. So that was all for this video talking about the reflection of light. The next topic is going to be refraction of light.